In this video, we are going to look at predicting the products of a single displacement reaction by using either the metal activity series or the halogen activity series. We'll start with the metal activity series. Metals, as well as hydrogen, can be ranked in terms of their reactivity. Reactive metals, such as potassium or lithium, are always at the top of the activity series, whereas unreactive metals, such as gold, are always at the bottom of the activity series. An example of an activity series then is given on the right here. So you can see reactive metals, such as lithium and potassium, are at the very top of the series, whereas gold is at the bottom. We can use the activity series to predict whether a single displacement reaction will actually proceed. So if you recall, the general formula for a single displacement reaction is A plus XY reacts to give X plus AY. Now there's a caveat as to when this actually happens. So both A and X are metals, and a single displacement reaction will only occur if A is more reactive. So if A is more reactive than X. That means that if A is above X in the activity series, then you will have a single displacement reaction occurring. If it falls below X on the activity series, no single displacement reaction will occur, and so we would write no reaction as the products. We're going to take a look then at two examples. Our first example is iron plus copper 2 sulfate, and we want to predict what the products are or if the reaction is actually going to occur. So what you're going to do is identify your two metals, iron and copper, and find them in your activity series. Here is iron, and here is copper. So in order for this reaction to occur, iron needs to be more reactive than copper, which means it needs to be above copper in the activity series, and in this case it is. So this means that a single displacement reaction will occur, and we will produce iron 2 sulfate plus copper. Our second example then is silver plus calcium chloride. So we want to find both silver and calcium in our activity series. So silver is here, and calcium is up here. In this case, we want silver to be above calcium in the activity series, but it's not. It's below calcium. So that means that it's not reactive enough to create this single displacement reaction, so there would be no reaction. You can write out no reaction fully if you would like to, but more commonly in chemistry, we just write NR as no reaction. The second type of activity series we're going to look at in this video is the halogen activity series. So halogens also follow an activity series in single displacement reactions, and what's really nice about this activity series is it follows their same position in the periodic table. And what that means is that fluorine, which is at the top of the periodic table, is the most reactive, followed by chlorine, then bromine, and iodine, which is at the bottom of this series, is the least reactive. We can then take a look at single displacement reactions where two nonmetals switch places. So if we're looking at this one here, fluorine is reacting with sodium chloride. So we want to look at and see, is fluorine more reactive than chlorine? So looking at your periodic table, you're going to notice that fluorine is above chlorine in position, meaning that fluorine is more reactive. So this single displacement reaction will occur. And that means that the nonmetals are swapping places, so we're going to create chlorine, and we're going to create sodium fluoride. Our second example, iodine reacting with calcium bromide. So again, you're recognizing that we're looking at the two nonmetals. If you locate those in your periodic table, you're going to see that iodine is below bromine in this activity series, meaning that this reaction will not occur.